right, so we're back now. We are moving on from surface area to take a look at volume. So just quickly, let's take a quick skim through what volume is going to look at. So we're looking for the volume for three-dimensional objects. So we're looking for the amount of space an object takes up. So while when we were looking at surface area, we were looking at the amount of space the outside of the object is. Now we are looking at the amount of stuff you could put in that. So if we imagine we have a box, it's open, but that box is full of stuff. How much stuff is in that box? And so that could be like filling a box of popcorn, filling a fish tank up with water. One way to think about it is you've seen a Rubik's Cube before, right? It's got all these different sides. And so thinking about how many cubes can go inside a box. So if we have a box like this, we could fit 1 cube, 2 cube, all these things are also three-dimensional that we're putting into it, right? And so what we're thinking about, how we call this, when we take our measurements, we measure these in cubed dimensions. So centimeters cubed, meters cubed, whatever. Sometimes you might hear it as a cubic meter instead of meters cubed. Both would work. And so regardless of what we're looking at, our equation generally is our volume is the area of the base times the height. And so that changes depending on what we're looking at. So if we're looking at a rectangular prism in this example right here, we've got the base right here, this shaded spot. And so we could calculate the area of the base, as it says right there, and then multiply it by this height right here. Okay. If we were looking at a triangular prism, it's a little bit different. If we look in the name right here, rectangular prism, that means the base is going to be a rectangle. If we look at a triangular prism, that means the base is going to be a triangle. If we look at a cylinder, that means the base is going to be the circle. So even if it is shaped like this, we are imagining that, or we're flipping it. Oh, wow, that art was terrible. We're flipping it on its end so that the base is actually this triangle. Boom, right there, because it's a triangular prism. The triangular, that's the base. And then our height would be this area here. Or if we had flipped it up, this would be our height right there. Does that make sense? It's a little bit of thinking, but I think you will rock it. If we have a cylinder, same thing. We have the area of the base of the circle and then multiplied by the height. So let's take an example here that we can take a peek at. The base area of the base of a fish tank. So we've got a fish tank. Wow, this is a rough sketch this evening, but that's okay. All right, so we've got a fish tank. On the bottom, the area of the base of that fish tank is 30 centimeters. What's the volume? So we know our base, we know our height is 30. We know this area is 2013 centimeters squared. So we take our 2013, we multiply it, our area of our base, we multiply it by the height, and we're left with 60,390 centimeters cubed, because this is centimeters squared, and this is centimeters. That becomes centimeters cubed, because centimeters times centimeters is centimeters cubed, right? So now we have centimeters cubed, which is centimeters times centimeters times centimeters. That's going to equal centimeters cubed. We just want to reiterate that for the units. So the units are always important in volume and in surface area. So, well, in everything really. That's it on this one. We're going to look more specifically into rectangular prisms, triangular prisms, and cylinders, and calculating out their volume as we go. This is just a quick little intro to kind of get you ready for it. Awesome. Stay safe. We miss you. We'll see you soon.